Okay, so I know what you're thinking right now. Yes, I know that. You think, oh, Ms. Ramos, this ionic bonding topic is too difficult. And even though you post two videos on the stream of Google Classroom, this topic is very difficult to understand. Today, we don't have any internet at school. That's why I have decided to use my critical thinking skill and my creativity just to create this video. Okay, so please watch this video as many times as needed. Ionic bonding. What is the ionic bonding? Electrostatic attraction, okay, between particles that have opposite charge. You have the cation, that is the particle that is positively charged, and then you have the anion, which is the atom that has a negative charge. Why positive charge? Cations. What are the elements that are going to form cations? The elements that are going to form cations are the metals. Why the metals? Because you learned when you were learning about trends that the metals, they have a low ionization energy and they have a low electronegativity. So the tendency of the metal is just to lose electrons. Okay? So the metals are the ones that are going to form cations, positively charged particles or atoms. And then you have the anions, which are the ones that are going to be formed by the non-metals. Why the non-metals? Same explanation. High ionization energy, so high that they can steal electrons from another atoms, and they have high electronegativity, which is the tendency just to gain electrons, see? And that's why they become negatively charged. Now, why, Ms. Ramos? Why do the elements combine? Why do they have to combine? It would be so, good that they stay by themselves. See, so we don't have to learn about this, but that's not real life. See, why do they combine? Because they need to reach chemical stability. How they're reaching chemical stability? By having 8 electrons in the last level of energy, and that's the octet rule. And I think that the octet rule was part of your vocabulary activity. What does that mean? That they're going to have in the last level of energy, see, with the exception of level 1, because you know that level 1 is going to be able to hold up to 2 electrons. Okay? So, on the last level of energy, level 2 all the way through 7, they need to reach 8 electrons in order to gain chemical stability. Okay? How that stability is going to be reached, what's going to happen, the metals, they're going to be losing electrons, and no matter they're going to be gaining the electrons. Okay? So, we're going to continue with this. How the bonding is going to be formed. And this is the periodic table approach. Okay? I'm not going to use over here the electron configuration approach because that electron configuration approach was discussed in one of the videos. And it's the long way. This is the periodic table approach because you're going to be using a periodic table. Let's say that beryllium, see, which is in group 2 and has 2 valence electrons, is going to be combined chemically with, I don't know, chlorine, which is in group 17, 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. See, this pair of electrons, this pair of electrons, and this pair of electrons, they are not ready for bonding because they are in pair. Remember? Pauli exclusion principle and Hunt rule. See, they are in the same orbital, spinning in the opposite direction. The one that is ready for bonding is that one. Now, that's not the case of beryllium because beryllium has 1 and 2 over there. Okay? So these 2 over here in beryllium, they're ready for bonding. Now, beryllium is combined with chlorine. You have a metal and a non-metal. So consequently, you have an ionic bond. In here, you have an ionic bond. What is happening during ionic bonding? The metal is going to be losing the 2 electrons. Losing. So it's going to become You know that? A positively charged particle. Yes, Ms. Ramos, you put the 2 over there, the plus over there, because it's going to become positive charge. But what about the number that comes after the sign? 1 and 2. And this number that you have over here is the oxidation number. Okay? Oxidation number is the charge of that atom after losing the 2 electrons. Okay? Now, what's gonna happen with the non-metal? Remember, in order to reach stability, this one is gonna be losing the electrons to gain that stability. This one is gonna be gaining just to have 8 in the last level of energy. 1, 2, 3, 4, 5, 6. It needs another one to reach chemical stability by becoming a negative ion. Okay? Yes, Ms. Ramos, we know that the nonmetals, they're gonna form negative ion, but what about the number that goes after that? How many chlorine has to accept in order to reach the 8? Only 1. And that number over here is the oxidation number. This representation, you have to put the grouping sign in there, because the grouping sign is letting you know, well, the grouping sign, no, the grouping sign and the oxidation number is letting you know that you have ions in there. Okay, so this representation is what we call in chemistry Lewis structure. The Lewis structure. So that's the Lewis structure, the representation for the ionic compound formed by beryllium and chloride. Ms. Ramos, how are you going to write the chemical formula for that compound? Chemical formula. Okay? Once that you have the symbol of the metal and no metal involved, and you have the oxidation number, you're going to switch that. And I was using a strategy when I was teaching my kids, okay, ionic compounds in physical science, from the oxidation number to the number of atoms that are involved in that compound. So you have to dance, baby, dance. And that's what we're gonna do here. So you have a 1 that goes here, a 2 that goes there, the 1 you don't need to put that over there, and then you put the 2 under the chlorine. What does that mean? That for 1 atom of beryllium, you're gonna need 2 of chlorine to form that ionic compound. Okay, if that number over here is called the subscript. Ms. Ramos, how we are gonna name that compound? The cation never change the name. So you have beryllium, because beryllium is the cation, so you're not gonna change the name. Anion, you're gonna drop the ending of the element's name, and then you're gonna add IDE. So chlorine is gonna become chlorine. That's the name of that ionic compound, beryllium chloride. And this is the chemical formula of that ionic compound. And you do the same, see? For any ionic bonding, you will follow the same strategy. Another example. Okay. Let's go and erase all of that. We're gonna do another example. Let's say that we have aluminum combined chemically with oxygen. So I'm going to start with aluminum, and I'm going to look on the periodic table. Aluminum is in group 13, 3 valence electrons. So 1, 2, 3. Okay, by the way, you know that that's the electron dot diagram. And what are you going to represent in the electron dot diagram? The valence electrons. Oxygen is in group 16. So 6 valence electrons. 1, 2, 3, 4, 5, 6. Remember that pair over there, this pair over here, they're not ready for bonding because they're already in one orbital organized, spinning in the opposite direction. Okay, now, Ms. Ramos, how we're gonna come out with a Lewis structure? You're gonna open your grouping sign. Aluminum is a metal. The metals, they form positive ion. Positive by losing electron. How many? 1, 2, 3. There you go. That's the oxidation number. 1, 2, 3. Okay. Oxygen is the non-metal. We know that the non-metal, they're going to form negative ions. But what is the oxidation number? 1, 2, 3, 4, 5, 6. How many more to reach 8? 1 and 2. So oxidation number is going to be equal to -2. And here you have your cation and your anion with their respective oxidation numbers. Easy piece of cake. Now, Ms. Ramos, how can we write the chemical formula? Easy piece of cake. You're gonna dance, baby, dance from the oxidation number all the way through. You look at my hands. I'm crossing them. I'm crossing them. See? From the oxidation number to the number of the atoms involved in the compound that was formed. What does that mean, Ramos? Remember, those are the subscripts for your chemical formula. What does that mean? That for 2 atoms of aluminum, you need 3 of oxygen to form this ionic compound. Ramos, those subscripts, they are going to be affecting the name. No. Why not? Because the cation never changed the name. Cation never changed. What is the cation? Go there. Aluminum. Aluminum. And now I have to analyze the anion. What is an ion? Oxygen. So I'm going to drop the ending and I have to add ID. 3 videos about ionic bonding. You don't have this in Ingenuity. You're not going to find this in Ingenuity. And then you're going to learn this in Chem 1 in college. You don't know that? My daughter's going to be making 25 hours to $25 an hour tutoring you. Okay? Super easy.